right, excellent. So when it comes to software delivery in general, there really are four large overarching challenges, right? One is just making sure that the code is secure as you're building out the code, right? We hear stories every now and then of pipelines and builds that just aren't secure. People can go in and modify that code ad hocly without anyone knowing about it, right? And before you know it, you deploy something that's broken out to your customers. The second thing is quality, right? Maintaining quality as you're trying to move fast, right? We know companies today, I don't care if you're developing physical products or digital products and solutions, software is involved in some way, shape, or form, either internally or externally. So you want to make sure that either your customers or your internal users have the best quality software so that they can do their job every day, right? And part of that is maintaining a good depth and breadth of testing throughout your process, right? To make sure that you are releasing high quality software out to your customers. And then thirdly is just, almost the opposite of that, right? Is the velocity piece, right? Everybody wants to move fast. Customers expect new features to come out in a cadence that satisfies them, but you need to do it in a way that maintains quality, right? But there's also other things that you can do by looking at your process. Are there manual handoffs in your process that you can automate, right? And continuously optimize that may help you with your, reduce your lead times and increase your velocity, right? Your deployment velocity, so that you are getting new features out to your customers, but those features maintain a sense of reliability and quality for the applications that they're using. So you're not breaking things, even though you're running fast. And then lastly, in the last 2 years, right, we've dealt with the pandemic. In work in general is just more decentralized now, right, and distributed. So we have teams working remotely all over the world. And how do you make sure those teams are working closely together while being remote, right? So collaboration is a key challenge today, and making sure that your different teams around the world who are working together for one common goal of sending out high quality software quickly, has the information that everyone can look at, so that they're all speaking the same languages when they're looking at analytics and trying to decide on what to do next. All right. So how do you do that, right? So there are 4 key metrics that have been out in the market for probably 7 years now by the DevOps assessment group, right? And they've run surveys for the last 7 years and have come up with these 4 metrics around velocity and quality that are a measure of how an organization and a product group are doing from a software delivery perspective, right? And they've come up with categories from high elite performance to high to medium to low performance, right? And it's based on these 4 metrics, right? The first one is how frequently are you deploying code, right? And they found that elite performers are deploying code 973 times more than their counterparts who aren't elite performers. They might be high or medium. But their lead times are also 6,500 times faster, right? Lead time from commit, so when code is committed to when that code gets deployed, right? And they're also recovering from incidents 6,500 times faster. So if code does get deployed that's causing an issue, they're recovering from that issue very quickly, to the point where it's probably not even impacting customers, right? And the nice thing is that while they're running fast, their quality is being maintained, right? They're 3 times lower instance where their deploys are breaking issues, right? Or causing issues and breaking code. So their change failure rate is 3 times lower. And this is from the last report that I have is 2021. I'm sure another one's going to be coming out soon. So the takeaway here is, being an elite performer may not be optimal for where you are today as a software development organization or product organization. But really the takeaway is find a way to get your hands on these 4 key metrics, right? And again, I'll show you how we can do it here at Sumo. But having some sense and some foundation of how frequently you're deploying code, what your lead time is for those teams that are committing code to deploy, what's the change failure rate as they're deploying things, what's the percentage of time that things are breaking, and then when things do break, how fast does it take to recover from those issues, right? So if I just get a hold of those 4 metrics, get a foundation, measure it, and then benchmark it, and then you can see how you can improve from there, right? So, and I know it's complicated, right? I think you've heard a lot over the last few years, right? That data is everywhere, data is siloed, it's in different tools, resides with different teams, and how do we get it all together, right? So I understand that, right? And I think we all do, right? Is getting a hold of that data, getting it correlated, normalized, so that everyone can see it, everyone can understand it and read it the same way. And we know that it is coming from these different tools, right? From Jira to Bitbucket to Jenkins to alert tools like PagerDuty and OpsGenie, from webhooks like Slack, et cetera, right? It's just a whole bunch of data. How do you get hold of it? How do you get it together? What's the right data, first of all, right? To put together. And then how do you make sense of it all to understand and boil it down to 4 or 5 key metrics that help you understand how you're delivering software today. Where do you need to improve so that you can increase velocity while maintaining or improving quality at the same time, right? So again, right, the key here is you're moving fast, but you want to balance that innovation with reliability in order to preserve that user experience, right? The last thing you want to do is keep throwing out features and code that constantly break your applications for your users, because then your users are just going to go somewhere else, right? So that digital user experience is key to maintain while making sure that you're delivering new features that your customers want. We understand, right? As I said, the DevOps toolchain is fragmented, right? There's a ton of data silos from all these different tools across the DevOps toolchain, right? And that causes limited collaboration across teams. Again, teams are distributed today more than ever, but then having the different data and the silo data just doesn't help, right? People are talking about different things, different languages based on different data. So you need that visibility, right? You need across that life cycle, right? In order to improve that productivity across the team so that you're all working together and you're deploying code frequently that's high quality, right? But I also understand, and I've talked to plenty of customers about this, where they've tried to do this in-house, right? They've hired people and engineers to create that data lake, gather all the data from the tools, create that data lake, and then try to make sense of all that data. And it's really, really hard. It can be done if you're a big enterprise with a big budget and you can hire 2 or 3 engineers to do it all. But let's be honest, right? If you have budget to hire engineers to do stuff, do you really want them spending time, collecting, correlating, normalizing data when they could be doing other stuff that is better for the business in your organization? So here at Sumo Logic, we're actually able to do that, right? We have an observability and security platform that includes a way to collect all this different data from across the DevOps tool chain, enrich it, normalize it, correlate it, so that you can get metrics around your software development process, and you have a better understanding of how your teams are delivering software to your customers, right? So you'll actually be able to increase your release velocity while improving the reliability of that code being deployed, but also the security of the code itself as it's being built in the pipelines, right? And then having a platform with normalized data that everyone across the organization can look at and view and understand means that now your different teams around the world are speaking the same language, they understand what's going on, and you can have data-driven conversations to find out where to improve, right, and get buy-in. So it's really about measuring how effectively you practice in small batches, right? So, and I'll show you this through our demo, where we've got certain features that allow you to track active development time by different teams, because we all know that most teams today are in a lot of software development processes are in microservices. So small teams, small batches, right, leading up to deploying code into an application, right, for users. So it is really understanding how the different teams are doing. Some teams may be doing really well. Some teams may be faltering. And first of all, you need to understand what teams are faltering, and then you can find out why, right, and improve that so that everything's working well. And then that can lead up to your overall DORA metrics, right? Your velocity and quality metrics at the highest level across all the teams, so that you understand truly as an organization how you're doing from a software delivery perspective. And then also keep an eye on the delivery process itself, right? You can drill down and understand what's happening with your builds, your pipelines, right? The different stages in your pipelines. What tickets are being created and what tickets are being completed, what tickets may be being held up and why are they being held up, right? Because that slows work down, which slows down your velocity, and you need to understand why. All right, so let's get right into the demo. Okay, so first of all, within Sumo Logic, right, we integrate with majority of the DevOps tools, right? So Jira, Jenkins, Bitbucket, GitHub, GitLab, OpsGenie, PagerDuty, all the different tools that a DevOps organization uses and engineers, software development engineers use, right? So, and this gets all normalized, correlated into our 4 key metrics here, right? So within your reports, we have a DORA metrics overview, which collects all that data from across the different teams and different tools and presents that in a single platform with normalized data so that you can see it, right? And you can understand it, you can baseline it and benchmark it, and then you can trend it over time and see if you're improving or not. Okay, so you can see your deployment frequency, you can see your lead time for changes, you can also see your change failure rate, and then any time to restore for any issues that might pop up after you deliver software, right? And again, I will stress that this is data demo, this is data environment, and this is some of the things that we pulled within Sumo ourselves because we are essentially a software company building software. But you also now have a pipeline overview, right? So this gives you a bird's eye view into your pipeline executions, right? You can see how many of pipeline executions happened over time. You can see alerts in the different services that triggered those alerts. You can see your deploys and which ones were successful versus failed. If you have more failed than success, something you may want to dig into, but we also break down the last 10 failed deploys for you. And the same thing with your builds. You can see your build status, success versus unstable versus failed versus aborted, and your last 10 failed builds. And then you can click into each build to get more detail. And then you can also look at issues for a particular project, right? In the issue status, which ones were done, completed. You've got a lot of undone here. So you may want to look into what those issues are, who created them, but also, is it possible that maybe the issue is, or some of these tickets that were created might be too big, right? So they need to be broken down because you don't have enough resources to really tackle them all. So breaking them down into smaller stories may help get those done faster, which leads to a better deployment frequency time. All right, so that's the overview, right, for your DORA metrics and for your pipeline. But then you can go one step further. You can actually start digging into your DORA metrics, right? So you can dig into your deployment frequency. You can see how many deploys per week. You can see your deploys by repository or repo, and do a 1-week comparison. And you can also change the data if you want to, right? I always have around 14 days, but you can go last 30 days or so, up to last 15 minutes. Okay, so you can see your deploys over time, right? So you can see how deployment frequency has gone up and then down. So it's kind of wavy. It's not very steady, but it's also interesting how it correlates with success versus failed deploys, right? You've got a bump here. So you might want to check this out as to why there was a big spike in failed deploys. Again, when you start seeing things like this, it should prompt you to start investigating more. There could be a bottleneck, could be an outage, right? What's causing that outage for these builds to fail? How long does that outage take to fix, and need to get it fixed quickly. So from a lead time perspective, now you can start seeing how you're ranking, right? With your different timeframes here, right? So we've got a minimum lead time of 241 hours. Our median lead time is 38. Our max lead time is 16. Again, this data is demo data, but you can see it ranks in the high until we get to our maximum, right? Which is low. And then you can actually see your pipeline durations and your lead time by team. So now you can start seeing what teams might be faster than others or slower than others, right? And if there's a couple of teams that might be really slower than others, it could be something going on there that you might want to investigate. Could be some new team members that came in and they're just taking time to come up. It could be vacation time, or it just could be something that's happening where either you need to add more resources to that team to get that lead time back up. You can also start breaking it down by repos, right? So you can see the repos with the slowest lead time. You can also see the environments with an average lead time. And then you can actually start looking at your change failure rate, right? So here you can see that 11.3% of the time that we deploy new code, there's a change that needs to take place, which isn't bad. We, based on our thresholds and our metrics internally here at Sumo, we post that as fine, and that's green. And you can see that the average change failure rate, right, trend over time, it's actually kind of trending a little down, which is great. But we have spikes here. So again, if there's any anomalies that are popping up causing these spikes, it might cause you just to kind of prompt you to take a look. You can also see if there are any particular services that are causing more alerts than others. And also any P1 incidents being caused by a particular service, as in DB engine versus all the others, right? So this may prompt me to go look at the DB engine service and the group running that, and finding out what's going on there. And then time to restore. So this takes us about 30 minutes to restore from an incident when an incident does occur. Again, you can break it down, your P1 incidents, by service name. You know, again, you saw the DB engine having spikes again there, and then the database engine as well. Those two seem to be the biggest culprits out of all of them. But again, just one level down so you can kind of filter out any other noise from the overarching DORA metrics and really get down into individual services, repos and whatnot that could be causing things to slow down, right? And the last thing you want is a team of developers waiting because they're waiting for either a build to finish for another group, or something happened and work is stopped and it's not getting their way. It's not coming their way. So again, it's all about maintaining a good, efficient software development and delivery process, and having those metrics and analytics to understand, is it an efficient process or is it not an efficient process, and where are things breaking, if they are breaking, and what can I do to fix them? And then the last thing I want to show you is our development and delivery time. So this is a little different. This really isn't part of DORA metrics, but it's something that we added because we always got questions about how can I want to break down like how well individual teams are doing from a lead time perspective, right? I know I've got different teams doing different work, and I want to know how they're doing and what their average, development time is, and what's their average review time to review code and merge code, right? Because what's not good is if you've got code that's sitting in a repo waiting to be merged, right, and reviewed and merged, and it just sits there for days, either because someone's on vacation again, or someone left, or someone's out sick, right? So, and that drives up your lead time. It also drives down your velocity, your deployment frequency, right? Because work essentially slows down or stops, and that's just not good. So this kind of breaks down active development time and review time by different teams, and you can see who on the different teams and what they're doing. Okay, so that if you have a spike in development time, or more importantly, a spike in time to review and merge code, again, you can see that, be proactive, and get ahead of it before it causes a problem downstream and delays your deployment of new features out to customers. All right, so let's go to our CI/CD pipeline monitoring. So this starts breaking down the overview, the pipeline overview, right? So now you can do that one click down into your pipelines, right? So you can start seeing alerts in those pipelines. You can start seeing which ones are high versus low in the number. You can see what services triggered or had alerts triggered, and what teams were responsible for those triggers. Okay. You can also look at what were the high priority alerts that were triggered within your pipelines, and the service, the team responsible, and the priority. And then you can go into the alert ID itself through PagerDuty or OpsGenie, whatever tool you're using at the time. And you can trend it over time, right? So you can see the number of alerts created versus closed, right? So they're pretty close. And then you can also look at the high priority alerts by service, right? And again, you look at DB engine, right? They're spiking again, like you saw in the earlier screen, but also, where is it? Database engine, right? So the blue and the purple. Again, that one click down lets you kind of focus in on certain issues, certain problems that might be slowing work down from a software development delivery perspective. You can do a click into your build as well. So you can start seeing how many builds were done, right? And this is for the last 24 hours. And what the results of those builds were, right? Were they successful, aborted, unstable? What services and the number of builds, right? And the builds by team. You can also trend your successes and failures over time, right? And look at failed versus success. You can look at the last 10 failed builds and your last 10 successful builds, right? Again, this lets you understand, are there any of the last 10 failed builds were any from a critical business service, right? Like an e-commerce site, or ticketing site, or maybe a contact management system that your salespeople use, right? And if that's the case, you need to get on it quickly. All right. You can also break down your deployments and find out what's going on specifically for your deployments, right? So you had 240 deploys over the last 24 hours. You had 88 that were successful and 153 that were that failed. This is a big number to me, and I would probably dig into what those were and why. You can look at, again, the correlation here. You can see that prod seemed to be the culprit here with most of the majority of the failed builds. And you can do a one-day comparison, right, by environment, service, and the status. You can also look at your deploys by repository and where those deploys came from. You can look at it by service and by team, right? Your failed versus successes, right? So you can see the payment failed, 142 deploys for the payment service failed. It's a payment service. People are transacting on the service. That is something you definitely would probably want to look into very quickly to find out what's going on, troubleshoot it, remediate it, and get that back down. And then you can just get a summary of your last 10 deployments, right? So by date, environment, the status, again, a lot of failed here versus success. Make me start doing some investigation into the commits, but also the team involved and why it's failing a lot. And then you can also break down your issues, right? So again, you got to remember, right? These things are being pulled from Jira, Jenkins, your Git data or Bitbucket data, and then your alerting tools like OpsGenie, PagerDuty, et cetera. So here you can look at how many issues were created versus closed and then reopened. So 3,800 reopened is a big number to me. I'd probably want to look into why they were reopened, right? Did they just time out? Did they not get done? Were they in the backlog and then suddenly someone took it on? Again, are they too big, right? Where maybe the stories need to be broken down into smaller stories so that someone can pick it up and get it done. Okay. You can see your issue by status and by type, right? So was it a task? Was it a bug fix? Which is great. It's the only small service request. You can see it by priority, right? Highest, major, medium. Nice to see that the highest priority is low. And by project, right? So what projects have the most open tickets or most tickets? And then why, right? With help desk having a ton of tickets tells me that there's some issues that customers are experiencing. So they're going to they're opening up help tickets at the help desk, right? And again, these could be external customers, or these could be internal employees that are trying to use an application to get their job done, and something's broken. You can trend your issues over time versus to do, done, and complete. And the average time it takes to close an issue by project, right? So app dev takes the longest. Again, might want to look into why that's taken so long, right? Again, are these stories too big? And do they need to be broken down, right, to smaller stories in smaller chunks? And then you can also look at the top 10 issues that took the longest to close and really dig into what they are. Looks like a lot of them are help desk tickets. Okay. And then pipeline stage monitoring, right? So, this lets you understand how your pipelines are doing, right? Are they executing correctly? Are the builds getting done? Where is the activity taking place? And then you can start looking at your execution count, right? So 178 came from the master versus the build test, right? 181 for the build test execution. And then you can also look at your stage execution by count and where they are, but also look at your failed stages, right? And what services they end up. So again, just visibility into your actual pipeline stages, what's happening at each stage. Are things flowing smoothly? Is work flowing smoothly through that pipeline and things are getting done? Or are things breaking, right? Where are they breaking? What is that causing work to slow down and therefore causing lead times to go up and your deployment frequency to go down? Or are things breaking as they get pushed to production, causing issues and causing your change failure rate to go up, right? So you can look at your average duration in seconds. Again, the regression test taking the longest. You can also look at your 20 slowest pipeline stages, right? Again, maybe there are things in here that might be manually based, right? Maybe there's some automation here that can help you bring some of these down. And then you can get a pipeline summary, the last 10 failed stages, and the 20 lowest pipeline steps. All right, and then lastly is your pull requests, right? So this gives you an idea of what's happening with your PRs, right? And how many were created versus how many were merged and declined. Again, with this demo data, it's 9,300 in the last 14 days. Is there a reason why they were declined, right? Did the test fail? Did the code break? And then moving towards your service, you can start looking at your PRs by the top 10 services, right? And how many there were, right? So the Java backend has the most. That's okay, I guess. And then you can look at your PRs by target branch and your top 10 reviewers by assigned, right? So by name, you can look at, you might want to know why Samya is getting so many requests to review PRs when you've got 10 other folks on the team. Again, could be just the way the team's broken up. But again, seems like an awful big burden here for Samya. Is there a reason behind that? Is there someone, maybe she needs another hand to add a resource, or someone's out sick or on vacation, so she's the sole reviewer here. But again, that tells me that, you know, this has a potential of slowing things down, right? If she's be responsible for reviewing so many PRs, is she getting other work done, right? Is that her sole job? I doubt it. You know, and adding a second pair of hands, would that help get things done faster? And then you look at the average time to close for the reviewers, right? And that's pretty even. And then repos by average time to close, right? Again, pretty even until you get to the service here. And then you can also look at it, merge versus decline over time, right? So you've got a spike in created PRs, must have been a project obviously going on, which is fine. And then they all kind of level off. Right. That's it for SDO. I'm going to see if there's any questions. It's 1:34. I'm just going to do a quick, I also want to let folks know, look, if you don't want the whole SDO solution and you just want, hey, I just use Jira, or I just use Bitbucket or OpsGenie, that's fine too, right? We have integrations with Jira, Bitbucket, and OpsGenie as apps, or just standalone integrations. So you can get a bunch of detail just on Jira, right? You can look at how your issues break down, open, created, closed, reopened, by type, by component, right? Just gives you a visibility into your tickets, right? And what's happening with different projects that those tickets might be assigned to, and who's doing what, right? By assignee, open and closed by assignee. You know, are things getting done relatively quickly? Are things falling behind? Are things falling into the backlog, and why? If you just are a Bitbucket user for some of your repositories, you'll get a whole bunch of information, but just on the overview, again, you'll get just a good idea of what's happened with your Bitbucket information, right? Really your PRs, right? So pull requests and builds, deployments, you'll get a summary. So all good information here to understand better understand what's happening with Bitbucket users. And then lastly is OpsGenie. So mostly for alerts, right? So this breaks down your OpsGenie data, right? Around the alerts, what the different events are, the events over time, created versus acknowledged versus closed, not acknowledged, what alerts were escalated, right? And then by source, alerts by team, by priority, by recipient, and by tags, right? So again, gives you that some good information and insights into your alerts, who's doing what to fix them, who submitted them, what's the priority levels, right? Are priority ones really high for some reason or not? And again, just good information to have around your OpsGenie data. All right. So that concludes our demo of software development delivery optimization. I want to thank you for your time.